What's up, YouTube? It's your guys, the Hotshot Hotwires, back at it again with a banger. Hope you enjoy our video about water in space.
I'm going to be talking about water for human space travel, especially on the International Space Station. Why is water so important? Well, it's obviously needed for the astronauts to survive. It's needed to hydrate freeze-dried food and powdered drinks. It's needed for personal and oral hygiene. It's needed for experiments. And it's needed for electrolysis to produce oxygen. Issues with water on the ISS. The water must somehow get aboard onto the ISS, but bringing water to the International Space Station is very expensive because it's so heavy. It can cost NASA anywhere from $3,500 to $10,000 for every liter of water brought to the ISS, and it must last for long-duration space flights such as one entire year. Solution to this problem. 93% of the water that is used is reclaimed or recycled. People lose water from many different sources, and it can be recycled from these sources to prevent waste. These sources include astronauts' breath, shower water, residue from personal and oral hygiene, astronaut sweat, and astronauts' urine for only NASA. In case of an emergency, there's a 2,000-liter supply on the International Space Station. Every time a new supply ship comes, they have to bring a little bit of water to make up for the 7% lost. And in the early days of the ISS, there was only like a 50% recovery, which is why there couldn't be too many astronauts at one point. This actually works. The International Space Station reclaims about 28 liters every day. NASA uses iodine and filtration to purify water, while the Russian Space Agency uses silver to purify water. It also produces a little less than NASA because it does not recycle its urine. Is this enough? Each astronaut needs about 0.43 gallons of water for drinking and 0.21 gallons of water to hydrate their food and drinks, which is about 0.64 gallons a day. 6 astronauts on the space station at a time, which amounts to 3.84 gallons per day used. Since about 7 gallons are reclaimed, if you subtract 3.84 gallons used, you still have 3.36 gallons left over every day for hygiene and electrolysis. The Sabatier System. The Sabatier System generates water by reacting the waste carbon dioxide from the astronaut's breath with waste hydrogen from the oxygen generator. Through this reaction, the Sabatier system can improve the water recovered to over 85%. The Sabatier system is also needed for future exploration, such as trips to Mars. This system converts waste gases on the International Space Station into methane and water. The chemical formula is CO2 plus 4H2 becomes CH4 plus 2H2O, which is saying that carbon dioxide plus hydrogen becomes methane and water. Methane, since it's highly combustible, is vented out of the space station into outer space. Carbon dioxide and hydrogen are already in abundant supply because carbon dioxide comes from exhaling and hydrogen comes from electrolysis. Since the reaction is really slow, nickel or aluminum oxide is used as a catalyst to speed up the reaction. This system produces about 5.5 liters or 1.5 gallons of water every single day. The Sabatier system diagram. So, carbon dioxide from the astronaut's breath, it's filtered and compressed, and it's combined with hydrogen from the hydrogen storage tank to make methane and water. The methane is kept in a storage tank to vent it out, and then oxygen is produced from the water splitting up into hydrogen and oxygen. That oxygen is used for breathing, and the hydrogen goes all the way back to its own storage tank so that it can be combined with the carbon dioxide to produce methane and water.
Thank you! Thanks for watching, guys. Hope you enjoyed it. Please slam a like, subscribe, and hit that notification bell as hard as you can.